So when we talk about put and patch, we generally talk about HTTP verbs. So we want to communicate with another system over HTTP. And it is important to know that put is part of the HTTP spec and patch came later, sort of like an add-on, and is discussed not even in the HTTP spec, but an entirely separate document. And I think patch derived from a lot of the frustrations around put. So the spec is actually very, very strict around put and says like put is full resource replacement. So what does that mean? Let's say we have a user object and that user object has an ID, it has a name, and it has another field that's called created at. And now we want to update this user. So we send a request to a URL that goes like users and then ID. And we send a request. So our initial name for our user was Josh. And we send a request. And we want to update the name to Jake, let's say. So we send a request with the user, and now we have to, according to the spec, to the way put is intended, we have to send a full representation of the user. We have to send the ID, we have to send the new name, and we have to send the created at field. And the new name would be, let's say, Jake. I forgot what I said earlier, but we updated the name. Now it's Jake. And one very important property of put requests is that they're idempotent. And idempotent means it doesn't matter if you send a request one time or 1,000 times. You'll always end up with the same resource state. So if the ID is 1, created at is, I don't know, something, and you send this request, you send it once, now the name is Jake, the ID is the same, created at is the same, or you send it 1,000 times. It will always have the ID 1, it will have the updated name, and it has the same created at field as before. So this is what idempotency is. You can perform an operation one time or as many times as you want, but you end up with the same resource state. Of course, there are intricacies here with our system state. You can send it too often and you can be rate limited, or the server can go down and then you get a 500. But if we only talk about two systems communicating via HTTP, idempotency means you send a request once or you send it 1,000 times, and ideally you end up with the same resource state. And idempotency is not by any means a property of everything HTTP. Idempotency, certain HTTP verbs in HTTP are idempotent or are required to be idempotent according to the spec, and put is one of these verbs that is required to be implemented in an idempotent way, but it is not true for all the HTTP methods. So if we look at this in a real life scenario, we can see a couple of oddities here when we look at put, and that leads or has led to some frustrations with put in the real world, especially when we're dealing with APIs and more complicated systems. So the full resource replacement, like it's a pain, right? You have to send all the fields. And the first thing we see immediately is we have the ID here and we have the ID there, right? And as programmers, we're usually told to not repeat ourselves, but yet we're sending redundant information in the same request. This seems a little odd at first glance, and like the spec isn't really doing us any favors here. The next thing we notice is that we include fields like the ID, but we also include another field like created at, and we have no intention of mutating any of these fields. Like created at is a field that is set the first time the user is created, and the ID is our identifier that is generally not updated in any way. But still, if we perform a full resource replacement, we're required to send these fields in our request anyway. And this can cause a bunch of additional work on the server. Not only do we have to ensure that this ID matches this ID on the server, we also have to make sure that all these fields that we have no interest in are of the correct shape, that they haven't been messed with or that someone isn't trying to expose any security vulnerability in our system. So we have to perform a bunch of validation for a bunch of fields that we're honestly not even that interested in. This is a bit weird, right? And the third oddity with put requests is that put requests, they require us to perform a full resource replacement. But in reality, like our resources, they're not even what we're exposing to our clients, right? In reality, in a database or the full record of a user may contain any number of fields that we only use internally. Like, let's say we have our hashed password. We may have all sorts of information on the billing state of our users, or maybe just some other values that we use internally, like the status of the account. We never expose these fields. These are meta information that we maybe use internally, but that is never exposed to the user in any way. So if we now have to perform a full resource replacement, does this mean we're even allowed to keep these fields in a resource? Does it mean that we have to expose them to the user? Does it mean the user has to send them back to us when they want to update the user? All of these things are very weird to handle if we're being very pedantic to the spec. And this has led to a lot of frustration, and also to most companies, also very large companies like Twilio, for example, becoming far less pedantic with put requests in general, and implementing them in a way where they say like, yeah, full resource replacement, see you later, we're not doing this, just send us the fields that you're trying to update. So in this case, just send me the name and just give me the ID and the URL, and we're good. We perform the update, and that is fine by us. And it is that sort of frustration with the spec versus what we need in the real world to perform updates to resources that has led to the creation of patch, of the patch method. So as you probably already can guess, so patch methods allow us to do exactly this. They allow us, when we want to update a user, so we go to the URL users, and then we go to the ID, and we just send the name. Let's say this is already the updated name. Let's say this is Jake, and we send this request, and we send this to our server, and then it just gets propagated to the database, and everything is fair and well, right? This is a lot easier. We don't have to deal with all the validation between the ID in the body and the ID that we have in the URL. We don't have to worry about immutable fields that we have no interest in updating in. We don't have to validate them. We don't have to sanitize them. We don't have to prevent that any of these fields that we don't want to update accidentally, by any sort of programming mistake, make their way into our database. So this is far easier already. And when you ask a lot of people what's a patch request, they will tell you exactly this. But this is actually not the entire part of this story. This is more the frustration that a lot of people had with put. So they implement patch in this very idempotent way as well. Here we're also very idempotent, right? We can perform this request one time, but we can also perform this request 1,000 times. The new user will always be named Jake. We'll always perform this one single update, and we implemented this in an idempotent way. But when you look at the RFC for a patch, patch is not required to be idempotent. Patch can absolutely be implemented in a way that is not idempotent, because patch requests are not just partial updates to any resource that contain a partial representation of that resource. Patch requests, the only requirement for patch requests is that they contain a set of instructions of how to manipulate and change a resource. And the way you want to change a resource, that is completely up to you. So let's say you have a company, for example, and the whole point of your company is you manage different timers or counters for users. So a counter that counts from 1 to a billion or something. And whenever a user wants to update a counter, they make a request to this URL that says like counter, and then they give you the counter ID. right? And in the request, they give you, so if this was a normal patch request, the same way a put request would be implemented, they would give you a counter request that goes like counter, so like a partial representation of that resource, and it would contain count, and that count would be maybe 1001, right? So count is a field that lives on our counter. And we set the value of count. But of course, that's not really what a counter does, right? A counter, usually when you work with counters, you wanna increment them. So what you send instead is a request that says increment, and then you increment by 1. And in response, you maybe get back a part of the counter that says counter, and the counter is now at 2. And then you send the next request and you say like increment, and then the counter is at 3. So you increment by 1. And you do this again and again and again and again, right? And by the end, the counter is maybe at 1,000. So this is absolutely a way to implement patch. So you send a set of instructions of how to change a value or change the state of a resource. But this way of dealing with patch is absolutely not idempotent, right? Because you send the same request. You can send this request 1,000,000 times, but you definitely change the state of the system. You don't always get the same answer. So you send it 1,000,000 times and your counter will be at 1,000,000, right? This is certainly not idempotent. Another way of implementing patch in a way that's not idempotent is to send a file diff, for example, something you would see like in Git, send this, right? This also manipulates the state of a file, but it is just a set of change instruction. It does not give you the full new resource state. So it's not just a partial update of an existing resource. It defines a set of instructions on how to change something. And this is the essence of patch. And this is also the big difference between patch and put. Put is a full resource replacement that is focused on partial or full representations of a resource. And patch is often used to describe partial changes to a resource, but patch can really be used to perform any sort of instructions to change any sort of state or any sort of resources in our systems. So yeah, I hope you liked this explanation. I hope it made sense to you and you don't have to watch any more videos on the topic. If you liked it, leave a thumbs up. See you soon. Bye.